Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed hydration of an alkene, Markovnikov addition of water, and stereochemical outcome. Moving on to the next step. The starting material is but 2Na, CH3, CH is equal to CH, CH3. The question shows the product as CH3, CH2, CH of CH3, which is butane 2-ol. This product has one chiral center at C2, the carbon bearing the OH group. Moving on to the next step. H3O plus protonates the double bond to give a secondary carbocation at C2 or C3, which are equivalent here due to symmetry of but 2Na. Water then attacks the carbocation. The carbocation intermediate, sp2, planar, is achiral and water can attack from either face with equal probability. And for the final step, because the carbocation is planar and achiral, nucleophilic attack by water occurs equally from both faces, producing equal amounts of R, butane 2-ol and S, butane 2-ol. This equal mixture of two enantiomers is called a racemic mixture. A mixture of diastereomers. Diastereomers require at least two stereocenters. Butane 2-ol has only one chiral center, so the two stereoisomers formed are enantiomers, not diastereomers. B. Optically active. A racemic mixture is optically inactive because the optical rotations of the two enantiomers cancel each other out. C. Optically pure enantiomer. This would require a stereospecific reaction with a chiral reagent or asymmetric induction, which does not occur here. Therefore, the correct answer is D. Therefore, the correct answer is option D.